Hello everyone, I welcome you all to this channel on Mac Talk. Today we are going to see the definition of fluid. Finally, we will summarize all that whatever we are going to study today. So let me start by defining this term, which is fluid. Now this fluid is something in which we consider two things mainly. One is gas, another is liquid. In gas you can take air as an example. Even steam and water vapor is also considered as gas in fluid mechanics, and in liquid you can take another engineering fluid, which is water. So these both are engineering fluid that we have taken as an example. These are the basic examples that we are familiar with. Now let me tell you what fluid is in terms of fluid mechanics. So before that, you need to understand, if you want to understand what fluid actually is, before that you need to understand what is shear force or shear stress. So let me tell you what shear stress is. Now what is this stress? Stress is something which is the internal resisting force acting opposite to the force that we have applied on a body. Let's say this is the compression force I am applying to the body to shorten it, but there is some internal resisting force which comes into play in order to create some resistance or internal resisting force against this compression force that I apply. So this internal resisting force will be known as compressive stress. See, one thing is clear from here, that whenever if I am applying a force on a body, if that body is opposing that force or creating some internal resisting force against that force which I have applied, then that force is known as stress. Now here in this case we are studying shear stress. That means the force we are going to apply will be shear force, obviously, and that force will have some resistance from the body. See, if there is no resistance produced by the body, then I'll not be going to have any stress at all. So if I want stress, that means the body must resist the force that I'm applying on it. So in this case we apply shear force. Now what is this shear force? Shear force is the force which is applied on a body parallel to its cross section on which the body is lying. Let's say this is the cross section that I have considered here, on which our body is lying, and I want to apply shear force on it. So what I said is, the shear force is the force which acts tangential or parallel to the surface in order to create slippage deformation in it, or to separate it in layers. So if I want to apply shear force on a body, I'll be going to apply some force which is parallel to this cross section. So I have applied this force, shear force, which is parallel to it. I can apply this shear force in this way, in this way, in this way. So all these are shear forces which I have applied parallel to this cross section. Now if I change my cross section this to this, then the shear force will be this will be the shear force, this will be my shear force, and the force which will be acting perpendicular to the cross section that I have considered will be known as normal force. Now this is clear to us that what is shear force in terms of strength of material. Now let me tell you what is shear force in terms of fluid mechanics, or while dealing with curvilinear body. Let's say we are dealing with a curvilinear body and there is some force that is acting on it, F. Now this is the theta angle, and when I break this force into component, this will become F cos theta and this another will become F sin theta. So this component F cos theta will be the tangential force, or you can say the shear force, which in this case of curvilinear body I'll be calling as tangential force. So this is the tangential force or the shear force. Now another force F sin theta was the normal force which I have applied on it. Okay, so in this way, this is the force which is tangential to it, and the force perpendicular to it is the normal force. So now we can understand fluid in terms of fluid mechanics. See, if I have this fluid and I want to create some deformation in it, let's say this was the liquid level, then I want to create some deformation in it. So how I will be going to have this deformation? Just by applying shear force. See, this is very important for us to understand, that if I have some fluid and I want to produce some deformation in it, then it is only possible just by the application of shear force on it. There is no other force I can apply on the fluid except shear force in order to create deformation or flow in it. Now there are some examples that I have taken here. Now the question arises, if I have this fluid, how is it possible that if I tilt this plane and this fluid will flow just because of the shear force? Let's say this is my fluid element on some plane, and I just tilt it to some small angle 90 minus theta, and then I see some flow taking place in this direction, which is parallel to this surface, on which it is lying. So in this way I can say the force that is applied on the body is surely the shear force. Let's say this is the weight which is acting downward in direction, and this is the angle theta. So when I break into component, this is w cos theta and that is w sin theta, and this w cos theta is the shear force which is here. Again, you can see the normal force is not the force which is causing it to flow, but the one which is what we call shear force, because shear force is something which acts parallel to the surface or parallel tangential to the surface of a body. Another example that you can take here is in order to understand that how it is always possible that whenever I am creating deformation in my fluid, I am creating it by shear force only, because there is no other force by which you can deform your fluid except shear force. But there is an exception in fluid. Obviously in liquid we can create deformation by shear force only, but in gas we can create deformation by compression and shear force both. So this is the only exceptional case we have, but in most of the cases the deformation that you will be going to see will be due to shear force that is acting on a body. So here I have this finger and I want to apply some compression force on it by pressing this fluid downward in direction. Even though it looks like that the force that I'm applying by pressing my finger down on this fluid, but it is not actually. It is this shear force again, and that will create some deformation by lifting this water up. And again, how is this possible that even if I'm applying some compression force to the fluid, then again I'm creating some shear force, not the compression? How is it so? Because the outer surface of this finger is separating the fluid layer from it, and that is something which is applying the shear force which is parallel or tangential to the fluid. Another case you can take here is, suppose let's say you have this straw and you want to suck, and now you are saying I'm not applying any shear force at all, but again you are applying some shear force from the internal surface of this straw, and that is again creating some shear force. So one thing is clear here: if I want to deform or want to have flow in my fluid, I have to apply some shear force on it, some shear force on it, some shear force on it. Now let's summarize this all. As we have said, a fluid is a substance that deforms continuously when subjected to even an infinitesimal amount of shear stress. Even the amount of shear force that we are applying, if it is very small, then also you are going to see some deformation in fluid. And next we have seen what is shear stress. We have seen the shear stress is the shear force is the external force acting on an object or surface parallel to the slope on or plane in which it lies, the stress tending to produce shear. And the next definition could be force tending to cause deformation of a material by slippage along a plane or planes parallel to the imposed stress.